So 4.3 has gone forever. This textbook chooses to put a lot of topics in each section. So you will notice that we will spread the sections out, and we'll do a book assignment. We'll probably throw a worksheet in there because, like, these problems, if we weren't going to hit them again, that is definitely not enough to know what you're doing. Okay, so what's on there? So that I want to just make sure we got that. Okay, we know reciprocal identities already. We know that sine and cosecant are the reciprocals of each other, correct? We know that. I just haven't written them in this form. But if I told you sine was a half, you would tell me cosecant was 2, wouldn't you? So that's all this says. So sine equals 1 over the cosecant, but cosecant equals 1 over the sine, right? So I can go either way with those. That goes for cosine and secant, tangent and cotangent as well. The reciprocals, you know that. What we're going to be doing is we're going to be proving identities, so we're not going to have angles in there, we're not going to have values in there, we're going to be manipulating them into different things, into different forms. So we're going to be working with sines, cosines, and tangents without values to them. Quotient identities, we already know that tangent is 1 over cotangent, and cotangent is 1 over tangent, and we know that tangent is y over x, correct? So cotangent is x over y. So if I know that this equals y over x, what is y? What function is y? Sine. What function is x? Cosine. So that is why tangent is sine over cosine. Okay? And if tangent and cotangent are reciprocals of each other, that would mean cotangent is cosine over sine. So do you see how they all link? They just link together. Now, the Pythagorean identities are really fun. We have sine squared plus cosine squared equals 1. They're called the Pythagorean identity because guess where it comes from? It comes from the Pythagorean theorem. We could derive it from the Pythagorean theorem if you would like, but I don't want to right this second. And these two down here are different forms of that. I have 1 plus tangent squared equals secant squared, and 1 plus cotangent squared equals cosecant squared. I will expect you to know all of these and be able to use them. Okay? We can move these Pythagorean identities around and solve just for sine, couldn't I? Yeah. I could subtract cosine and take the square root. So the sine of theta would be plus or minus the square root of cosine squared minus 1. I love how it's off. I may need to recalibrate here in a second.
Is it recording?
Yeah, it is, but that's okay. So I can move those around and solve for them. But you notice that it's plus, right? And they are both squared. Sine plus cosine is not 1. It's sine what? Squared. Sine squared plus cosine squared equals 1. Now the other note over here is that sine squared theta is the same as just saying sine of theta squared. You notice I said sine squared, cosine squared. I didn't say sine, well, it's not sine squared theta, it's sine squared. It goes for all the functions. It's neater. The reason for that is if I had sine of 45 degrees, but I wanted it squared, it would look weird. If I put it on the 45, what would you do? They squared the 45, and it's not squaring the 45. You take the sine of 45, which is square root of 2 over 2, and then square it, which would be 2 over 4, which is a half. So that's why it goes on the function. Okay. I want to talk about these two real quick. People tend to get confused what's with what, okay? Evan, why are you on your computer? Thank you. Okay, what function is in the denominator of tangent?
Cosine.
Cosine. Okay. What function is in the denominator of secant?
Sine. Cosine.
Cosine. Secant is cosine. Okay. So tangent and secant are paired together because cosine is in the denominator, and I'm gonna show you why in a second, okay? Cotangent, what's in the denominator, cotangent?
Tangent.
How about sine?
Sine, that's what I
Oh,
said.
okay. What is in the denominator of cosecant? Sine. So I'm going to show you, I'm going to take this, first Pythagorean identity, sine squared plus cosine squared equals 1, and I'm going to derive these two. You are never going to have to do this. I want you to know how they came about. Because honestly, the only one you have to have is sine squared plus cosine squared equals 1. But you don't want to do this every time. I promise you don't want to do this every time. Okay, so I'm going to recalibrate real quick just so I'm not hitting everything twice. And what I'm doing is kind of it is a proof, and it's similar to what you are going to be doing. Not exactly, but similar. So if I start, you do not need to write this down. Okay, I start with that, yes? Okay, I want sine squared to be 1. I want that to be 1. How would I make it 1?
I have no idea. That's a really
You're
good
gonna have
question.
to square root.
No, that if I square root, I get sine. If I want 6 to be 1, I would divide by 6, wouldn't I? If I want 28 to be 1, I would divide by what? 28. So if I want sine squared to be 1, I divide by
sine squared.
sine squared. And if I divide sine squared, I have to do what?
Do it on both sides.
Do it to everything, don't I?
Yeah.
So to everything. So this is 1. Yes? And what is cosine over sine?
0.
No, it'd be
Cotangent.
Cotangent. And it'd still be squared because they're both squared, correct?
Yeah.
And what's 1 over sine?
Cosecant.
Cosecant. And it would still be squared because sine is squared.
I don't know how I feel about
So that's where the identity actually comes from. And again, you don't have to do that ever. I just want to show you where it comes from and why it's cotangent and cosecant. Okay? So I'm going to start off again with the Pythagorean identity. Can I write this cosine squared plus sine squared equals 1?
No.
Yeah, because it's addition, right? I usually will say cosine squared plus sine squared. And I want cosine to be 1 now. So I divide it by what?
Cosine squared.
Cosine squared. And I have to do it to what? Everything.
That'd be tangent.
So this becomes tangent squared of theta plus 1 equals secant. And again, can it be 1 plus tangent squared or tangent squared plus 1? Either one of those will work as long as you have both and they're both positive. Okay? Could I move this around and make it equal to tangent?
Yes.
I'd subtract 1, wouldn't I? So if I had tangent squared would equal secant squared minus 1. And if I wanted just tangent, I would take the what? Square root and put a plus and minus in front of it, right? When I take a square root. So can I take these things and move them around and solve them for different things? Okay, so in a proof, it's like a puzzle. You've got to make the left look like the right, and that's what our goal is. So the sooner you know those identities that I just gave you, the better. Do you already know the reciprocal ones?
Yeah.
Yeah. And tangent makes sense that it's sine over cosine, correct? Because it's y over x. And if you know tangent, so do you automatically know cotangent?
Yes.
Yep. So the ones you really need to focus on are those Pythagorean identities, okay? And it honestly, it comes from an equation of a circle too, which we haven't talked about yet. Okay, what's x? What function's x?
Sorry.
Cosine. What function's y?
Sine.
And we're in the unit circle, so what's our
Radius.
5? So that's where it comes from.
Wow.
Okay, so let's use these things. Everything you do today, you know how to do this another way, but we have to use identities today. Okay? So you're going to be taking those first identities that you wrote down, and you're going to be using them to manipulate to find the other functions. Got it? And this one's nice. This one says cosine and tangent, but should I be able to find all of them?
Yeah.
Yeah, I think maybe we will. Okay, so when it says use identities, you have to show the identity that you're using. Does that make sense? And we're going to have, if I say all of them, we're going to have some reciprocals going on and stuff, right? So this is 0.6. We probably want to make that into a fraction, don't we?
Okay, so
3/5.
3/5.
So sine of theta equals 0.6, which is 6 over 10, which is 3 over 5. Okay? So we're going to use we're going to find all the other trig identities, trig values, but we're going to use identities doing that. I'm going to show you how you show that you're using identities. Okay? So we're going to start, we normally do sines, and then we would just go to what?
Or cosecant.
Cosecant, right? Because cosecant is the what a sine? The reciprocal. So to show I'm using identities, I just do this. And then I reciprocate it. See that? Okay. So then, we'd normally make ourselves a triangle and do the Pythagorean theorem and find the other side, wouldn't we? But we can't do that because it said only using identities. So then I have to think, okay, you guys want to go to cosine next?
Yeah.
Okay? Because you can't do tangent, because tangent you need sine and cosine, don't you? Okay, so cosine. What of those identities did you have on your piece of paper that had sine and cosine together in one identity? No, not tangent, because I don't have tangent.
The first one, sine squared plus cosine squared equals 1.
So we need to know the name. What is that? What kind is that?
Pythagorean.
Pythagorean. I want you guys to name them, okay? We have the Pythagorean identity, don't we? Okay? So the Pythagorean identity says sine squared plus cosine squared equals 1. You notice I didn't put the thetas in there because I'm not worried about them right now, okay? There's a theta there. They have to be the same, just like they have to be an x if they're the same, correct? So if I want cosine, I have to subtract sine squared, yes? And take the square root. So cosine of theta is going to equal plus or minus the square root, because these are squared, right? Of 1 minus sine squared.
What would be squared?
Because-
you're finding the square root of it.
Yeah, we have to do the subtraction before you do the square root.
Got it.
Okay, so do we know sine?
Yeah.
Yes, sine is 3/5. So now what do we have to plug in there? 3/5, and then we have to do what? Square it. So we have plus or minus the square root of 1 minus 3/5 squared. Okay, so square the numerator and the denominator and get what?
9/45.
9/25. We have to make that 1 into what?
25 over 25.
So 25 over 25.
16.
So we have plus or minus the square root of 25 minus 9 is
16.
16 over 25.
So it's 4 over
And the square root of 16 is 4
4/5.
4/5. Okay, plus or minus. Now, how do I know whether it's plus or minus? It depends on what quadrant we're in, correct? Yes? And it doesn't tell me, I know sine is positive, so that means I'm either in the first or the second, but it doesn't tell me both of them, does it? And cosine in the first would be positive, and then the second it would be negative. So it's still plus or minus 4/5. Once it tells me what quadrant I'm in, can I decide on that? Yeah, so if it said like a third quadrant angle, this would be negative. If it said a second quadrant angle, this would be negative. If it said a fourth quadrant angle, this would be
Negative.
Positive, it's cosine.
Now we can use.
Okay, now we have cosine, we can
Quotient
find,
identities.
not yet.
Why not?
Cosine, we're gonna go immediately to
Secant.
secant, right? So the secant of theta equals 1 over the cosine of theta, right? And the cosine of theta was plus or minus 4/5, so this is going to be plus or minus what? 5/4. Now we can go to the quotient. Okay. So tangent of theta equals what over what? What function over what function?
Sine over cosine.
Sine of theta over cosine of theta.
Yay.
So sine was 3/5. And I think your book will drop the plus or minus at this point, but technically it's still going to be there, right?
Yeah.
Cosine is 4/5. And we've talked about this. We're dividing fractions, so we multiply by the reciprocals, right?
Yeah.
And if the denominators of both the numerator and the denominator are the same, they're going to reduce out, aren't they?
Yes.
So it's just going to be numerator over numerator and be 3/4. And it's plus or minus, but we don't know what quadrant, right? So we don't know what quadrant it's in yet. But so we just have to pay attention. Some of them will tell you, some of them will not. Okay. So I have tangent. I need what now? Cotangent. Now we have two choices. We could use ratio or reciprocal, correct?
Yes.
So we could use cosine over sine. Or we could use 1 over tangent,
Which is easier.
which is easier. So 1 over tangent would be 4/3. But do you see how I showed the person that looks at my paper how I got this?
Yes.
I used my identities. So when it says on a quiz or a test, use your identities, you have to show me you used your identities. Got it? Okay, tangent is 1/3. We're only going to do cotangent and secant right now. Does that work? Okay. We did all of them on the last one. Could we do them all again? Yes. Okay, so this is kind of fun because tangent is 1/3. So what do you know sine is already?
3.
1.
Oh, yeah.
What do you know tangent is already?
3 over
3. Well, yeah, you don't know what the denominators are, but you already know it's a 1 and a 3 for the numerator, right? Okay, so cotangent. How are we going to find cotangent?
The reciprocal of it.
Okay,
1 over
so-
tangent.
1 over tangent. I can't use cosine over sine this time, can I?
No, because we don't.
Because I don't have them. And I don't want to find them right now, do you?
No.
So it is what?
3.
3. Then I want secant. So what identity do I have tangent and secant linked?
Pythagorean.
The Pythagorean identity. And that is 1 plus tangent squared equals secant squared. So, oh, this one's easy. I don't have to move anything around. I just have to take the what?
The square root of 1/3. You have to square.
Well, I have to add, yeah, I have to do all that. But I have to take the square root of both sides, right?
Yeah.
So secant of theta is the square root of 1 plus tangent squared. Okay, so the tangent of theta is what? What is the tangent of theta? 1/3. So 1/3, and then I have to do what with it?
Multiply it by
I have to square it.
and then put
So
3
1
over 3. 1 over 9.
9. So this becomes 9 over 9.
So 10 ninths.
So 10 ninths. Now, and it is plus or minus, yes?
Yeah.
Okay. This is like taking the square root of the numerator and the square root of the denominator.
So we start at 10 over 3.
So it would be plus or minus the square root of 10 over 3. And if I had to rationalize it, I would have to rationalize it, correct? If I had the square root of 2 in the denominator, I'd have to multiply both by the square root of 2. I'd have to do all that fun stuff. Again, I don't care what the book does, I will not accept a non-rationalized solution. So, if it's a decimal, you need to make it a fraction, don't you? I mean, you don't have to, but I don't want to square 0.6. I'd rather, or I don't want to square 25. I'd rather have it 1/4, wouldn't you? So, make those decimals fractions. They're easier to work with. They really are. Questions, guys? Okay, so the next thing we're going to do with them, these were finding the other values. The next thing we're going to do is just going to have fun with the actual words. We're not going to do anything really other than what it says is use the trig identities to transform the left side of the equation into the right side of the equation. Okay? So they don't use the word yet, but you are writing a proof. Okay? When you write a proof, there's things that you're doing. You are only simplifying. We are only looking at the right side of the equation. The difference between simplifying and solving, like when I solve, I can add or subtract to either side. I can do things to both sides, right? I can't do that here. I can't. That other side is only to tell me what it's supposed to look like when I'm done. Got it? So you know the answer. The answer is 1. You got to get me there. The other thing is we need to go straight down. So all these little equal signs should what? They should line up. So you don't want to write it this close to the side of your paper. You want to give yourself a little bit of room. Some people, since we write from left to right, correct? Some people, if I'm trying to make the left look like the right-hand side, they'll rewrite it like this. Does this change it if I do this? No. You could rewrite it like that. So then it would be really easy to line up your equal signs, wouldn't it? So it doesn't matter, but they do need to be lined up. And then we have something special we do at the end that I will show you in a second. Okay, so we need to get these two things to be 1. To be 1. Okay? So what do you know? Well, sign's pretty much sign, right? If you want to leave it that way. You don't have to. You can change it. I like to work with sines and cosines just because we do that a lot, right? Do we have, when I want something to be 1, I want the same thing divided by the same thing, correct? Like dog divided by dog, that equals what? 1. 7 divided by 7 equals 1. Negative 28 divided by negative 28 is 1. So I need to get the same thing. So do you want to change the sine into cosecant or the cosecant into sine?
Cosecant into sine.
Okay, so what is cosecant in terms of sine?
1 over
1 over sine. So you have to write yourself sine times 1 over sine. You notice that the theta I dropped. See that? I didn't put it in that second step. You don't have to have it in the middle steps, but it has to be at the beginning and it has to be at the end. Got me? Mm-hmm. When we get into double angles or adding angles or subtracting angles, you're going to have the angles because you'll have 2 different angles. You'll have an alpha and a theta or something like that. So if I have 2 different angles, they have to stay there so you know. But this is all alpha. This is all theta, correct? So we're good. So, well, if I have sine times 1 over sine, what do I get?
1.
1. So this side is 1 and this side is 1. You notice I didn't keep writing the 1, did I? You don't have to. You didn't change it. So are we done?
Yes.
Okay. So we have to tell the world we're done. And you put this mathematical mic drop.
What?
And it's a square. It's a box. It says you're done. Prove me wrong. If you go to your book and notice, every single example in the book has a little square at the end of it. It's completion. You're done. I'm done with it.
It's like a period for math.
It is. It's the period in math. Every problem you solve is a proof. It technically is. I'm going to get a little bit picky on these because we're proving just formulas. But other than that. So now, what do you think you want to do over here? Left look like the right. So we want to get this to 1 again, correct?
Can't you cancel out the cotangents?
Well, nothing cancels.
Because they
Well, reduce the
So could we
two.
multiply
We
it out?
should multiply them out, should we not?
Yeah.
Because don't those parentheses tell me to FOIL?
Yeah.
Yeah, that tells me to FOIL. What do you notice about the left quantity and the right quantity?
There's a plus and minus.
There's a plus and minus. Those are conjugate pairs, yes?
Yes, I remember.
What should happen with conjugate pairs? What should happen to the middle
The
term?
middle term is
It should zero out, yes? I'm going to prove it to you this time, but I'm not going to do it after that. Got me? If only the middle sign is different. If I change the sign of the first one, then the whole thing's off. Okay, so I got to line this up, so I'm going to write it first. Okay, so I'm going to, when I FOIL that, what do I get? Cosecant squared minus cosecant cotangent plus cotangent cosecant plus minus cotangent
Square.
squared. Okay, well, did I tell you those two would zero out?
Yes.
Yep. Now, we don't show that, guys. Just the next step is gone. Got it? So I have cosecant squared
Minus cotangent.
minus cotangent squared. So do I have an identity? Well, because cosecant is 1 over, there's a couple things I could do. Cosecant is 1 over sine, correct? Yes? And cotangent is,
And 1 over tangent.
Sine over.
well, if I turn this one into 1 over sine, probably want cotangent in terms of cosine over sine.
Cosine over sine.
Okay, so then I could combine them and I could work with that. Or I can go, oh, wait, squared, functions squared. What identities have functions squared? Pythagorean. Okay, so I see squared functions squared. Do I have one that has cosecant and cotangent together?
Yes.
Yes, I do. I have 1 plus cotangent squared equals cosecant squared, yes?
Ooh, which you would
Do you,
just add.
okay, just a second. Wait, you're totally right. I'm gonna let you talk. Just a second. Okay, do you see what I just did? I'm trying to transform it. Oh, squared functions. Do I have, Pythagorean? Do I have one that has it? Yes. I'm making those connections back to what I know, what I'm learning, right? Now Maddie's got it. What do you got, Maddie?
You just add cotangent squared to the.
You can subtract.
No.
No?
Oh yeah. No.
Well, okay, there's 2 ways we could do it. What way do you want to do it?
Oh, I was just gonna add cotangent to both sides.
Nope, we can't because we're not solving.
Why?
Oh, on this
No,
or this?
on that.
Okay, on this we cannot. We cannot cross that equal sign because that equal sign just tells me the answer. I'm only simplifying straight down. Thank you for making that mistake. There's 2 things we could do.
You could subtract cotangent from both sides.
On here?
Yeah.
Yes. She's saying I could subtract cotangent from both sides and I get 1 equals cosecant minus cotangent. And I could substitute this back in. Yes?
We already have that though.
Right. So what does this equal? What's this equal? 1. So 1 equals 1. And am I done?
Yeah.
Yes. The other thing I could do, this is an alternate ending. Got it? Because there's more than one way to do this. Alternate ending. I could have just used this. See this? And could I have made cosecant squared into this? Okay, so I could have had 1 plus cotangent squared minus cotangent squared equals, and then this would be what? Cotangent squared minus cotangent squared would be what? 0. So what? 1 equals 1. See that alternate ending? Yes.
I'm confused on how you went from cosecant squared minus cotangent squared to 1.
Because I took my Pythagorean identity right
Yeah.
here, and I solved it. I moved cotangent squared over here.
Yeah.
So cosecant squared minus cotangent squared, which is right there,
Yeah.
equals what? 1. By the Pythagorean identity, it equals 1, does it not? Yes. Now another option is some people do is right here, they say 1 over sine. I don't know if you want to write this down or not, just watch. Would equal cosine over sine, cosine squared over sine, yes? And these would both be squared. So I have 2 fractions, don't I? Do they have common denominators?
Yes.
Yes. So then that would give me 1 minus cosine squared over sine squared, yes? Well, 1 minus cosine squared, Pythagorean identity, yes? Because sine squared plus cosine squared is 1. So what's 1 minus cosine squared equal? No.
Sine squared. No.
Sine squared plus cosine squared equals 1. So if I subtract this over, it equals sine squared. So I'd have sine squared over sine squared, which is 1. So I just showed you how many ways to do this. 1, 2, 3 different ways.
I'm not confused.
So you don't have to do it 3 different. Shush. You do not have to do it 3 different ways, do you?
No.
You have to do it how many ways? 1. And guess which way you do? The one that makes sense to you. Okay? So when you come in and say, I didn't get number 63. No, you're not even doing 63. 53. Okay? I'm going to say, what did you do first? And if you say nothing, I'll say do something and then I'll help you. Because if I keep telling you the way I would do them, are you going to develop your own way to do them?
No.
No. And you're going to be the one that sits there. I showed you a very simple one, and we had 3 different ways to do it.
How did you get cotangent squared minus cotangent squared on that one? Where did your cosecant go?
Okay, right here, with your Pythagorean identities,
Yep.
I have cosecant squared equals 1 plus cotangent squared, yes?
Yeah.
So I replaced that cosecant squared with 1 plus cotangent squared.
Oh.
I just did substitution. Every time you ask me, where did you get it, I'm going to say, okay, let's look back at the identities, because that's where I got it. You guys, so do you need to know those identities well?
Probably.
Yeah, and you're going to learn them by doing these, okay? So if you get stuck and you don't go to CalcChat for help or whatever, look at one step. Don't just write down the whole problem, guys, okay? Because if you don't make a connection with these, you're never going to get them. It's a puzzle. And we can't add or subtract things to the opposite side. We are working with one side. Let's do some more. I got 2 more, I think. Okay, tangent theta, cosecant theta equals secant theta.
I don't know.
So what do they all have in common? Like,
They all have a theta.
yeah, the functions themselves.
They all have a secant and like we put oh wait.
No? They don't, we can't like say Pythagorean, can we? They're not
No.
square. Well, can't they all be made up of what 2 functions?
Cosine and
Cosine.
Cosine and sine. Every one of those can be made up of sine and cosine, correct?
Yeah.
Yes?
Yeah.
Okay, so tangent is what?
Sine over cosine.
Cosine, sine over cosine?
Yeah.
Cosecant is,
1 over sine.
well, then what's the math tell me to do right now?
Cancel those out.
Reduce
So
the
1
signs.
over cosine.
And do not show me you're reducing the signs. I don't want to see it. We're big kids.
Oh,
I want the result.
1 over cosine.
1 over cosine,
Which is
which is,
sine.
which is,
secant.
which is secant.
Wait.
Oh, that's
Yeah.
easy.
How is it secant?
Because it's
Oh, cosine and secant. Yeah. Never
cosine and
mind.
secant are reciprocal. So that right hand side is just to keep your brain focused where it wants to go. That's good and bad. Because sometimes we get kind of inventive with our math. Like we do it wrong, we make up math that makes it work. But try not to do that. But you see what I did? I mean, you guys just,
Yes.
actually you did it. So when we do things, we kind of go with the flow. What's the next one tell me I have to do first, basically?
You get to square or foil it
I
out.
have to foil it out. Now, if those were,
And the middle signs are different, so.
yes, if they were squared, I maybe could apply a Pythagorean identity, right?
They're gonna be squared though.
They're going to be squared, and they are conjugate. So Maddie is right. The middle 2 terms are going to zero out. Yes, and I'm going to be left with what?
CSC squared
Cosecant squared.
and 1. Negative 1.
Negative 1. Okay, so your brain right now, bells should be going off. I have a squared function, yes,
Yeah.
with a negative. and I want it to be cotangent, and I have cosecant, do I have something that kind of links all that?
Oh, the Pythagorean.
I have the Pythagorean identity of 1
plus
cotangent squared equals cosecant
Secant
squared.
Wait, can we slow down
So-
for a second?
I'm not gonna finish it, I want you to finish it, cause there's 3 ways I could finish this one right now.
Give me a second.
See-
So I just had a question, Sadie, calm down.
Okay.
So when you were saying like 1 plus cotangent squared, equals cosecant squared, could we add that with like the equal signs, or do we have to do that? as
That's
separate?
off to the side. None of this work is shown, like I didn't show I'm reducing or anything like that. Evan, you had a question? Oh, you had the answer? Okay, you can do it for me when everybody else has tried it.
I think
Because I'm hoping people did it a couple different ways. Hoping.
Yeah, I don't.
Well, maybe I did do it right. I don't know.
Yeah, I got stuck. I don't understand how to do this.
I think I did it, Miss Mary.
I don't
Good.
know if this
I did it.
line up.
But like, I
How
just
do you
put 1
write the
equals 1 and
answer
then put a
into
box
that?
with the fill.
That's really good. It wouldn't be 1 because it has to equal cot squared.
You just put it there.
Cot.
Cotangent. Okay, Evan, how did you do it?
I just subtracted the 1 to the other side.
You cannot do that.
You can't. You
Why?
can't do it.
Oh, wait. On the proof or on the
On
the-
identity?
That's
Yes, on
what
the
I like.
identity.
Okay, thank you.
I
Because on the proof, can I do that?
No.
No. Okay, so on the identity, he subtracted 1 to the other side.
And
So
then
he has
equals what we have.
cotangent squared
Equals
equals
That's the same
cosecant
thing as we
minus
have
1.
above.
So then you use substitution, yes?
Yeah.
And did cotangent squared theta equals cotangent squared.
What if I skip that?
That's what I did.
If
How
you
did you do
what,
that?
skipped one step.
The middle part because you know it's going to be equal
I
to
just-
cotangent
oh, you
squared
have to
theta, so you
put
just
it-
write
I
it and
just
put them
thought you
off.
had to get
Where'd
that
you get
one.
the? I can't answer anything because I can't even hear her. You all need to quit talking at the same time. Kaylee, what were you
She
saying?
asked me.
Kaylee, what were you saying?
She's not paying attention.
Yeah, it doesn't matter.
So whatever.
Okay, well it's
I know
important.
what it is, but on the first one we put 1 equals 1. On these we put secant equals secant. What the heck am I supposed to put?
It wouldn't be 1 equals 1.
Okay, 1 second. You cannot skip steps in your proof. There's nothing to skip here. Okay? This bottom line needs to look exactly like that. If it doesn't, it's wrong.
Okay.
Okay. You are making the left look like the right. The right is only a guide. You got me?
Yeah.
This bottom line has to look exactly like that. Your thetas have to come back in. All that has to go. Sadie,
How did cosecant squared minus 1 become cotangent?
because the Pythagorean identity, that's why. Okay, guys, this is an algebra equation. 1 plus x squared equals y squared,
We're
correct?
not confused on that part. We're confused on how.
I don't get how you're confused that we
When
subtracted
you
1.
have cotangent squared equals cosecant squared minus 1, and then you write cotangent squared equals
Because
cosecant
That's
squared.
why.
Because that is that.
There, and then you just put it as cotangent since that equals that.
Got it.
No, that's what I've said 5 times. That's why I don't know how else to say it. Because
Okay,
I said
got it.
exactly what
Well,
you said.
sometimes it
One-on-one
takes
for
6 times
this.
to
Yeah,
get
Okay.
you have to take them
Shh.
I'm gonna need a one-on-one.
Every time you guys say, how did you do it, I'm going to point you to the Pythagorean identity. This is not part of the proof. I don't want to see it anywhere on your proof.
Wait,
But we can have it below,
right
right?
there.
You can have it on the side, you can have it somewhere else. It is not part of your proof. It is part of you manipulating an identity to fit. Okay? These are very, very short proofs. Very. We will get 10, 12-step proofs.
Oh, that's good.
Okay,
Oh, we will.
we will work on, not today.
In the next 30
Everything today will be 3 or 4 steps and you're done. Okay? Could I have done this differently? Yes.
Yes, we
I
show
could
that.
have done fractions with this. I could have done 1 over sine squared, got common denominators, then used my sine squared plus cosine squared Pythagorean identity. I could have done this 3 different ways. It doesn't matter which way you do it as long as what you do holds up with your identities and your algebra. Got me? I think that is the last example I have. Yes, because that is tomorrow.
Angle of depression.
And that is
That is, at least math and our so that it comes to person.